This lesson is lesson 19 of Unit 10, solving equations containing rational exponents. We'll be covering pages 336 and 337. You want to have your calculator and a highlighter. So in this lesson, we'll learn how to solve equations with rational or fraction exponents using the concept of an inverse operation. We know a lot about inverses. We use them every time we solve equations. Write the inverse operation for each of the following and then give a definition for inverse in your own words. We'll do a few of these. So we have the phrase adding 5 to a number. Our expression would be x plus 5. The inverse would be, we would subtract 5 from the number. Subtracting 7 from a number, that would be x minus 7. The inverse would be to add 7. Multiplying a number by a half, x times a half, the inverse would be to divide by a half, which is the same as multiplying by the reciprocal. Which would be 2, multiplied by the reciprocal 2. Let's jump down to squaring a number. Squaring a number, you take x and square it. The inverse would be to square root. And if we were to take the square root of a number, the inverse of that would be to square both sides. What about raising a number to the power 2/3? We have a number x raised to the power of 2/3. We would raise to the reciprocal power would be the inverse. Which is 3/2. So an inverse operation is an opposite or undoing operation. Remember that radical expressions can be represented with rational or fractional exponents and vice versa. For example, the square root of x is equivalent to x to the fractional exponent 1/2. The cube root of x squared, the root, remember, is the denominator of our fractional exponent. That's equivalent to x to the 2/3. And 8 to the 1/3. In radical form, that's the cube root of 8, which is actually equal to 2. So let's review reciprocals before we start. If one side of an equation is raised to a certain fractional power, raising both sides to the reciprocal power will unlock the side. So raising both sides to the reciprocal will unlock that side. What's the reciprocal of 1/2? 2. The reciprocal of 2/3? 3/2. The reciprocal of negative 4/3? Negative 3/4. Okay, so here we go. To solve equations containing fractional exponents, we want to isolate the base with the exponent using algebra if necessary. Raise both sides to the reciprocal exponent to cancel the exponent, solve, and then check in the original equation for extraneous solutions. You must check. Isolate the base with the exponent. Well, in number 1, we have 3x minus 2 raised to the 1/2. It's on the left-hand side all by itself, so we are going to raise each side to the reciprocal of 1/2, which is 2. That takes away the exponent on the outside here and leaves us with 3x minus 2 equals 49. Add 2 to both sides, 3x equals 51. Divide by 3, x equals 17. check. Make sure we check. 3 times 17 minus 2 raised to the 1/2. Does that equal 7? And yes, you can grab the calculator if you want. Parentheses 3 times 17 minus 2, close parentheses, raised to the 1/2. That is 7. So x equals 17 is our solution. Okay, here we want to get this by itself. We need this isolated. The base and exponent, we need to isolate that. So add 12. And divide by 3. 5x minus 4 raised to the 1/2 equals 4. Now we raise both sides to the reciprocal of 1/2, which is 2. 5x minus 4 equals 16. Add 4, 5x equals 20. Divide by 5, x equals 4. Now check, back into the original. And the original is 3 times, or 3 parentheses rather, 5 times 4 minus 4, close parentheses, raised to the 1/2, minus 12. Is that 0? Yes, it is. We did a calc check. X equals 4 is our answer. Number 3. Okay, raising both sides to the reciprocal of 1/3, which is 3. We have 2x plus 1 equals negative 5 raised to the power of 3 is negative 125. Subtract 1, negative 126, divide by 2, x equals negative 63. Checking. Parentheses, 2 times negative 63 plus 1, close parentheses, raised to the 1/3 is negative 5. Calc checked. Number 4, x minus 1 raised to the 2/3 equals 64. The base and exponent are isolated. Raised to the reciprocal power, 3 over 2. X minus 1 equals, this is the square root of 64 raised to the power of 3. Right? We do the root first, or you can use the calculator. 64 raised to the 3/2, 512. That was the same as 8 raised to the power of 3. Add 1, x equals 513. Check. Parentheses, 513 minus 1 raised to the 2/3 is 64. Let's say calc check worked. Number 5, we want the a to the 3/2. We need to get that by itself. So add 32 and then divide by 4. A to the 3/2 equals 8. Now raise both sides. The reciprocal of 3/2 is 2/3. A equals, that's the cube root of 8, which is 2, and then 2 squared is 4. Checking. Try this by hand. 4 times 4 raised to the 2/3, no 3/2, sorry. Minus 32, does that equal 0? This is the square root of 4, right? The 2 in the denominator is root. Square root of 4 is 2. Raised to the power of 3 is 8. 4 times 3 is 32. I'm sorry, 4 times 8 is 32. And 32 minus 32 is 0. It checks. Number 6, we want to get this c plus 2 raised to the 3/4 isolated. Subtract 6 from 30, and that's 24. And then divide by 3. 24 divided by 3 is 8. So we have c plus 2 raised to the 3/4 equals 8. Now raise both sides to the reciprocal of 3/4, 4/3. C plus 2 equals, the cube root of 8 is 2. 2 raised to the power of 4 is 16. Subtract 2 and c equals 14. I'll check that in the calculator. 3 parentheses, 14 plus 2, I know is 16. Raise that to the 3/4. Oh, yeah, I said 14 plus 2 is 16, and I typed in 16 instead of 2. It is 24 plus the 6 is 30. So we did a calc check. C equals 14. Number 7, already isolated the base and exponent, so raise to the power of 2, reciprocal of 1/2. X plus 30 equals x squared. Bring the two things on the left over to the right, so we have it in standard form. Factors of negative 30 that sum to -1 are -6 and 5. X equals -6, I'm sorry, x equals 0. Okay, rewind. X equals +6 and x equals -5. Checking, that's square root, so I'm going to check by hand. Is 6 plus 30 raised to the 1/2 equal to 6? Yeah. The square root of 36 is 6. That checks. Is -5 plus 30 raised to the 1/2 equal to -5? 25 raised to the 1/2, that's the square root of 25, which is 5, equals -5. No, that's extraneous. Our solution is x equals 6. Number 8, let's see, raising both sides, well, squaring both sides, right? Raising to the power of 2, that removes this, and we're left with 12x equals x squared. And it's quadratic, so standard form, subtract 12x. Factoring out a GCF. Setting each factor equal to 0. X equals 0 and x equals +12. Checking. 12 times 12, does that equal 12? Yeah, the square root of 144, sorry, 12 times 12 raised to the 1/2, does that equal 12? Yes. That checks. How about 0? 12 times 0 raised, the square root of 0, does that equal 0? Yes. So we have the two solutions, both 0 and 12 here. And our last problem base and exponent are already isolated. Another square root, so we square both sides. 14 minus x equals x minus 2 squared. Let's make sure we multiply this out. X minus 2 times x minus 2. X squared minus 2x. Minus 2x is negative 4x. Standard form. Add x and subtract 14. And the factors of negative 10 that sum to negative 5, that sum to negative 3 are negative 5 and positive 2. Set each factor equal to 0. I usually skip this step and go right to the solution of positive 5 and negative 2. And we need to check. Is 14 minus 5 raised to the 1/2 equivalent to 5 minus 2? That's 9. Square root of 9 is 3. 3 does equal 3. That checks. About negative 2. Is 14 subtract negative 2 raised to the 1/2 equal to negative 2 subtract 2? And 16 to the 1/2 is 4. Does that equal negative 4? No. The negative 2 is extraneous. Our solution is x equals 5. And again, thank you for your attention.